Okay, good afternoon, everybody. I'm here to talk to you primarily about Aurora and how fantastic Aurora is, but in a specific use case. My background is in content management. It's something I've been doing for a very long time. In 1990, I co-founded Documentum along with Howard Chow, and for approximately the next 11 years, went and helped build the enterprise content management business. Yes, it was that long ago. And I left because, I thought it was enough time. And then I went and I got kind of itchy. And so I went and created a company called Alfresco as open source. And so I've been doing this content thing for a long time. And one of the hardest things is getting content at scale, like really big content repositories. So I'd just like to talk about that today. So what we'll be talking about is what does it take to actually scale to billions of documents? And what are some of the architectural approaches that we can take to actually make this work? Now, I know a lot of you in the audience actually work for other software companies doing similar sort of things, and I hope you get something out of it. Some of you may actually have this problem, that you have a lot of information that you need to get it under control. So I'd like to talk about some of the use cases of content at scale, and then how can you support user applications so that people can actually use the information and access it really quickly. And then how do you move from really big data centers, which is what it takes to do that today, and just do it on Amazon, and specifically Amazon Aurora. So just a little commercial here. This is about my company, Alfresco. So we started it in 2005. Despite my accent, I've actually been living in the UK for 20 years. And I come over about once a month, and that's how I keep it up. But my wife's English, my kids are English, and I can't even tell if you're speaking, if you're English or American. But anyway, went and got some money from Excel to actually go off and start this thing. And I have to say, it was incredibly liberating to go from a proprietary model to an open source model, to be much more collaborative. And so as a result, we built up this big community of developers and people just downloading the application. You can just go to alfresco.com, download it, and give it a try. We got lots of partners, system integrators, and there's quite a few system integrators in the audience today. And just go ahead and start using it, building applications. And our business, because we started in the UK, tends to be very balanced, more or less 50-50 between the US and Europe. But we've been able to build up enterprise customers, about 1,800, and spread across many different industries, government and finance and media and a whole bunch of things. So based upon the heartbeat, our enterprise product, we believe, is managing about 7 billion documents with about 11 million users. And so this is all supported by a company of actually getting close to about 400 people right now. So here's some examples of some of the customers that are using it. A lot of government customers. Actually, NASA was probably the first government customer. A lot of healthcare. Healthcare seems to like open source, probably for longevity of information. A lot of manufacturing customers, transportation, logistics, a lot of software companies as well. Now, why? So it wasn't just about open source. We wanted to make it different. So we wanted to make it simple so that people actually use the software. Although we created some really powerful software, Documentum, not everybody used it. So that was a really important thing, to be able to do that. So we added some capabilities to do that. And then we made it smart, so you didn't have to do a lot of work. Stuff just happens in the background. And then we made it open, very open. Open standards, open source, just be as transparent as possible. We started with enterprise content management, and then we started to move into more process. Now, that's the end of the commercial. My marketing department has an Apple Watch. So if you just go to that website and fill in the form, There's also another way you could do that, which is just tweet. Follow me at John Newton, and just go ahead and I will follow you back, and then you can DM me your details, but just give a tweet and make sure it's something intelligible or whatever, and you will actually double your chance of getting that Apple Watch. So just keep that in mind. So end of commercial. Now let's just go to the main story here. So the story starts somewhere deep in the Nevada desert, not too far from Las Vegas, in a deep, secret, underground location where there's a really big data center and someone's trying to store 1 billion documents. Now, in some ways, maybe some of you think, 1 billion, that's not so much, and some of you are thinking, wow, that's a lot. Just to give a perspective on what 1 billion documents is, or billion pieces of information, there are about 5 million articles in Wikipedia. There's about 15 million articles in all the languages of Wikipedia. So, that doesn't even come close. If you were to search for Donald Trump on Google, you would get 190 million hits. If you were to search for Kim Kardashian, you would get about 250 million hits. So maybe we're kind of getting that range. If you search for the word Amazon, you will get 1 billion hits. So that's kind of the scale that we're talking about here. It's actually really hard to generate that much information. We just throw the word billion out all the time. It just doesn't really mean much. But if we're talking about information that people have created or information that actually has meaning, that's a heck of a lot of information. And we're actually talking about, for computer scientists in here, order of magnitude a petabyte of information. So it may be 10 petabytes, it may be 1/10 of a petabyte, depending on whether it's 100K, 1 meg, 10 megs, whatever. This PowerPoint presentation is about 25 megabytes, and it would have been bigger if I had actually added in all of the sound effects that I wanted to add into this presentation, but Amazon wouldn't let me add any more bytes into this presentation. So anyway, some people have actually tried to do this on things like SharePoint. You can sort of do it. There's this thing called a SharePoint farm, and you can put a fast server on top of it. And if you take and create 1 million servers on that farm, you could probably get that done. That's probably a bit of an exaggeration, but certainly 1,000 servers, you might be able to do that, because it can go beyond 1 million, but in general, it doesn't go beyond 1 million. We actually tried to do a benchmark of loading in 10 million documents into SharePoint, and that is not the easiest thing to do. We actually asked some people at Microsoft, how do you do this? Well, if you want to load 1 million, you take 100,000 and then copy it 10 times. Well, that's not what we're talking about here. We're actually talking about real live situations where we want to take information and actually go and store it. And this is really important because we have some of the most amazing transformations happening in enterprises today. In fact, some of the stories that we hear are actually the leading edge, the bleeding edge of what's happening in digital transformation. The effect that the cloud can have, the effect that social can have, the effect that mobile access to all this information can have, the effect of analysis on all this with big data, and then feeding that back into the business is creating whole new business models. We're not just redesigning IT, we're redesigning business processes. And what comes out of this is more information than we ever thought possible. And yet, we got to get control of it. We kind of went away from the control metaphor to, hey, do whatever you want metaphor. And that doesn't work. You can't find anything. You can't use anything. And here's where you can't find them. Here's some examples of some of the use cases at scale. We have enterprise document libraries And actually, I can think of an organization in the UK where they take all the documents on all the laptops and be able to store it. That is 1 billion documents for this very large department of the UK government. A lot of medical records, personnel records. When you're getting into companies with hundreds of thousands of employees, you will have a lot of that information. Transactions, invoices, purchase orders and stuff like that kind of generate up to that sort of scale as well. The single largest repository that I have heard of, that I can think of, is actually the Bureau of Indian Affairs, which has 7 billion documents that they need to take and manage. Why? That's a really long story, but it's very complicated and it has a lot to do with casinos. So, and a lot of tribes just kind of coming out of the woodwork here. Claims processing, a lot of research and analysis, actually generating a lot of information that needs to be captured, clinical notebooks, real-time video, and the Internet of Things. Where those two collide is actually body cams on police officers generating lots and lots of information. In the UK, there's actually the same number of police as there are in the city of New York. So when you start to count up all the information that exists in all the police departments in the US, that's a heck of a lot. And then discovery, litigation, loans, and policies. And actually, claims and loans is where this presentation actually came from, and our road to Aurora actually came from. Insurance companies consistently, the largest ones, consistently manage 1 billion pieces of information, if not more. Probably a lot more when you get to the biggest organizations. Now, what are they doing with all that? What are some of the applications? Well, one is just go ahead and browse, search for all the information, retrieve it, view it, mark it up. It's also a lot of file sync and share. When you connect a lot of desktops, laptops, mobile devices, and you start to sync back and forth, and you start to collect everything that's on your desktop, that ends up being a lot. Business process management, where you start to drive these processes, capture things on forms, have the users on websites actually interact with the information. That can create a lot. Scanning in huge amounts of information to free up real estate, that is huge, especially in the developing world. Records management, I already talked about Bureau of Indian Affairs, but hey, look at the GSA in the US. Media management, a lot of you have a lot of really big media files, video files, game files that need to be distributed and used and manipulated and brought together. We are talking about petabytes often for stuff like that. Case management is actually taking and focusing from a task perspective on that claim, on that policy, on that one thing that you're supposed to be doing at that moment, and then moving it on to the next one. And then just a basic information archive. We are the back end of Obamacare. Now, we were not the problem. It's the web guys that were the problem. Consistently, we were there, everything was fine, and we were doing maybe about $250,000 an hour when the deadline was looming and everybody's saying, oh my God, I have to go sign up because I don't know what happens next after that. So a lot of archiving is also one of the applications. Just store and retrieve, have APIs on top of it. Now, what is this content that we're talking about here? Well, if you're a database guy, and my background is very much databases. I actually ran the database group at Ingress Corporation, which was, Ingress was my first job out of Berkeley. And you can think of it as, hey, a line in a database, can't you just store it as a blob? Yes, but to go from those actual use cases to actually putting it as a line of data in a database is a lot more complicated than it looks. And part of that is because people tend to think in terms of files. Files are far more usable things. Files, almost by definition, are human things as opposed to data in a database. We take and we store that, but there's no organization, no control, and you don't even get the transactionality you get out of a database. And then there's a whole genre of new software as a service being presented, things like Dropbox, Box, Google Docs, actually taking and synchronizing with your desktop, taking and storing it away, maybe providing some basic level of access of that information. That's enterprise file sync and share. And the analysts generally think of this as something very different because content and ECM is much different. ECM is today a $6 billion industry. That's how much stuff people are putting in. That's the software side of it. And they expect, the analysts expect it to grow to about $9.5 billion by 2018. It's actually accelerating because of the trends that we're seeing in terms of digital that we mentioned before. But it's so much more than a file. It's so much more than a line in a database. It's things like the different renditions that you have. It's the controls that you have in place. It's the presentation of its context in relation to everything else. It's the business process that moves it from one department, one person to another person. It's also taking and extracting, transforming, and using the bits inside of the file for various different types of purposes. And so there's this much richer model than just a file or just a line in a database. There's many different ways that we might want to access it. You know, we might want to browse through a directory to get to it. We might want to do very sophisticated searches or very easy searches, filtered searches to be able to access the information. Or we may just want to have some APIs to directly access it. But we have at the core this content object that has its own identity. You know, each one has its own security policy. It has its own place in the index, its own metadata. It has its own set of renditions. So for instance, this PowerPoint presentation will be available in a PDF as an example, or it may actually be turned into a video or something like that. And we can have some object-oriented capabilities around it and aspect-oriented capabilities by adding types and categories and relationships between these. These are the sophisticated capabilities that you need when you're actually using it in various contexts. And then there's a whole lot of other contexts that are driving these things, anything from social activities. How are people actually using this? To how does it fit within the process? How does it fit within the task? How do rules take and automatically organize and move the information around? How can we take the semantic concepts out of a document and help relate it to other information so we can auto-classify that information? And then it sits on top of an infrastructure that's more than just a database. It's search, it's distributed, it's sometimes a SQL database, sometimes it's a no SQL database. Now, content at scale, what do we actually mean by content at scale? Well, there's a lot of different dimensions to this whole thing. It could be a lot of users simultaneously writing or simultaneously accessing. Most of the big numbers you hear in context of, you know, I heard something like this morning about how a media company serves up 100 gigabytes a day or an hour or something like that. Yeah, but so what? It's the same thing being presented over and over and over again. A lot of users at scale, storing and accessing is much different. It can also be distributed all over the place. Scale as in geographic scale, where a bank can be in London, can be in New York, can be in Tokyo, can be in Sydney, Australia, and everybody wants to access everything as though it's right there, right next to them, and yet have everything synchronized, which gets us to the problems of concurrency. How do we know that that's the right information? How do we get the referential integrity between two pieces of information to know that it's accurate? I'll give you a really good example. If I am taking and storing information from Salesforce through Salesforce and I put something in, if I come right back in, I want to see that information right there. That's the referential integrity, not just within itself, but with other systems. It can be just the total number. We talked about 1 billion. We can talk about 10 billion. Or we can just talk about size, petabytes. half a petabyte, 10 petabytes, 20 petabytes. Now, how do you manage this? The industry is full of different players in here. We mentioned SharePoint, there's a Documentum, which I started, there's FileNet, there's OpenText. All these guys, at some level, have done 1 billion documents. But in doing so, it's kind of a wobbly thing sometimes to try and put together one of these things. And you don't necessarily have the redundancy in place. When you actually set up all the pieces to make it run, there can be a weak link in here. Also, usually I have to buy huge amounts of equipment to make this thing run. Ideally, we'd just like to expand out to the peak loads and then come back down. Provisioning this thing can be months, and there's the purchase process, there's the wiring, there's the configuration, there's the setup. Where do we put it? How do we put it in a place that's easily accessed? And then once we do it, what about next year? What if it doubles? What if it only goes up by 10%? What if it goes up by 10 times? There's a lack of agility with the current approach. In fact, it's enough to get you fired. So there's some unique challenges of very large repositories. There's scaling up. That's one way to do it. Just get bigger machines, cluster them, cluster the database, cluster the indexes, get some read replicas so that the read is not taking up a lot of the CPU. Or there's the scale out. We can shard this. Sharding is a very common approach to solving this problem. Or just say there are multiple repositories handling different pieces, we'll federate across those, which is kind of just a variation on sharding. We can take and replicate, or ideally there's shared nothing so that we can just go ahead and access and add more and more machines out there. These are the different approaches we can take. And we have taken those approaches. The traditional vendors have, we've taken those approaches as well. But is there an easy way to be able to go and do this? So let me just give you a flavor of what is inside of our system. We have a user interface called Share. Share is a simple interface for either searching, browsing, sharing, check in, check out, do the basic types of things. And it's a platform in and of itself where people can add other capabilities. This sits on top of a repository that provides all those capabilities we talked about before in terms of case management and workflow and everything else. And then we also have a search index as well. We use Solar for that, to be able to take and find things quickly. Now, we take and store the metadata in a database, generally a relational database. And then we take and put the content in a file system. That was the approach that we took at Documentum. We went and benchmarked all the different ways that we can store stuff, and today it is still the best way to store information. And then the indexes are stored on some other file system. Usually you don't want to have any sort of contention between them. Keep them separate, allow them to be able to scale out. There's one other twist on here, which also adds to the big data problem of the whole thing, which is the workflow engine. The workflow is about not just review and approval, but it could be about distribution. It could be about how information is published from one place to another. Think of it as a state machine that goes ahead and makes sure everything is in its place at the right time and right place. Now, how does this fit within AWS? Well, we use Amazon RDS, and we'll use Amazon EBS or store it on ephemeral storage, or we can back it with S3 or Glacier, and basically we just go ahead and write through. We can cache it in the local store to be able to get it, and then we go ahead and take the Solar index, and we can either store it on ephemeral or we can put it onto EBS. And we're still experimenting with what the best way to do it is with the latest generation of EC2 instances. but you might have provisioned IOPS EBS for being able to take and manage your solar index. Now, that's a simplified view. What's actually happening underneath the covers is a bit more complicated. There's a lot of things going on. There's transformations, there's rules that are either working synchronously or asynchronously. People are building their own APIs, accessing the information. We have lots of APIs, protocols. We have all sorts of ways of putting stuff in and putting stuff out. We also have things like transformation services and reporting and analytics on what's going on with all the different elements there. And then the workflow engine, or the business process engine, which is called activity, has its own life as well, which can actually be independent of our repository actually being used with other repositories, other, say, a Documentum or even a Box or a Google Docs or whatever, moving information in and out. And you could be building applications directly on its own APIs. Activity is an Apache licensed platform, so there's lots of other people building applications, not just us on top of it. And then it sits on top of usually a relational database. The next version will be able to run on NoSQL. It also uses Elasticsearch, so we're kind of the English have this term, horses for courses. Use the right database for the right purpose. And in this case, Elasticsearch fits the process rules purpose. And then it can also add and manage its own files as well. Now, the way we get this scaled out is we scale it out in tiers. These are the major tiers that we're dealing with. Activity in its own set of tiers. Share, we'll go ahead and put that in a separate layer. We take the Alfresco repository, which tends to be a bit more CPU intensive in its own tier. And then Solar, we can tier it out with some read copies and some, read instances as well as write instances. And then the transformation services, basically when you put something into the repository, it will take and generate perhaps another form. So especially with media, be able to take and generate thumbnails or generate PDF renditions for Office documents or whatever. These are a set of just elastic instances off to the side doing some of these transformations. And based upon this whole thing, we have created our own cloud, which is myalfresco.com, using all these tools, but using some of the capabilities of Amazon with DNS and ELB. We have some high availability proxies, so if God forbid the East Coast goes down, then you go over to the West Coast, which happened a little while ago, and also Solar off to its side, and we're storing on RDS and S3. So we can get there, we can actually scale out all this stuff here, but it should be a lot easier than doing it the traditional way. Now, what is it that we're talking about in terms of scaling? Well, this is our Metamodel here. Basically, we have classes of documents, and a class can be a type, which is hierarchical. It's a single inheritance of types. And then we have aspects, which are kind of additional types. Think of them as Lego blocks of data that you can attach to the information. And a class consists of its own property types or associations, and child association of things like folder or maybe rendition or something like that are also being modeled in there. And then the folders are also being modeled as its own object containing documents and documents containing renditions. We can add aspects like whether it's versionable, auditable, and each of those has its own data. And then we take and we manage the organization. And this organization tends to be really important for a lot of people to make sure that everything is in the right place at the right time and that it's completely ACID. Now, the database schema that gets generated in here is a very flexible one. You know, we're essentially storing them as value attribute pairs in terms of the properties themselves. But we use a relational database because we want the transactionality that makes it a lot easier. I know you can get that with some of the NoSQL databases, but you go beyond some of the basic transaction concurrency locking. you might need to come at it from different directions, and it's just hard to get it to what we need it to be. And processes as well is kind of hard. So we will go ahead and we'll take and store all this stuff into tables, provide the concurrency, and if we were to take and store this, well, basically in something like an Oracle database, you'd have to stripe it across multiple volumes, and we want to get as much parallelism as possible. So, we've done sharding as well. We've also built an implementation on top of MongoDB as another way of getting to the actual scale that we need. And then along came Aurora. And, as I mentioned, my background is database. And I just know that when you get to a certain size, things just start to rattle and they're about to not quite work, and we'll get it through. I remember the first time that Documentum went through just the exercise of storing 1 billion documents. Basically, there was a guy babysitting it the whole time, and they weren't really doing it the right way. They were just storing rows in a database, to simulate what would happen if you went through an API. And basically, we need to take and we need to replicate it between availability zones and just make sure everything works. Well, I'm not going to go into the details of the Aurora architecture because there's been several sessions on that, but the way that they've structured it, I think, is actually really interesting. Actually just storing the log files in order and doing it on SSD and just using the inherent capabilities of Amazon and the redundancy and replicating from one place to another. I didn't expect to turn into a fanboy, but it was actually pretty amazing how it actually worked. And the fact that it's just self-healing. It's like yes, we should take backups because we're supposed to do that, but it's like snapshots have a new purpose, which is to just roll back to a certain state. Basically, when it runs, it's using an algorithm to figure out, what are the correct versions of this. With 9 different systems going on, if something goes down, if it's in the same availability zone, it should be, self-healed relatively quickly. And between availability zones, it's pretty fast as well. So basically, it just runs, and it just goes, and it just doesn't seem to fail. So in terms of the modifications required to make this work on Aurora, and that's it. It's just a blank slide. That's it. It's like, the guy running this thing, I said, well, what did you do to make it work? And he goes, nothing. It just looks like MySQL. It was like, so if you were here to learn how you make this run on Aurora, I'm sorry to disappoint you. This is just the way it works. And when I saw Debanjan, when I first met him, I go, yeah, my guy said it just works. He said, can you say that publicly? Well, here I am. I'm saying it. So it has been pretty amazing, and it just kept on going. And I'll talk about the benchmark in a second, but there doesn't seem to be any degradation in performance, which is something else that I would expect under those circumstances. And if only all of it could be that easy. Unfortunately, it isn't quite. Because then we get to Solar. We have somebody on our team, Joel Bernstein, who's actually one of the committers on Solar, and he's actually the architect of Solar Cloud. Now, some of you may be real Elasticsearch fans, and some of you may be Solar fans. And it really depends on what your use case is. I tried to get someone to definitively say, which is better, Elasticsearch or Solar? And you won't get a nice, easy answer to that. What I will say is Solar is good for the types of things that I'm talking about here. Documents, with like real text inside of it. It's really good for that. Elasticsearch is really good for data, where you want to slice and dice data, where you want to take and search for words and do all the things that you expect, you know, in a Google-like search capability, that's what you do there. Now, if only we could take an out-of-the-box Solr, that would be great too. But we don't, because we need to do some things out of the box, you know, beyond out of the box. So we're not just doing text extraction or whatever. We actually have to take the metadata that is from a different source and inject that with it, and also get the permissions. And we do things called shingling. So you know how Google automatically, you start typing and it makes suggestions and you think, how the heck did Google do that? Well, it's basically indexing pairs of words together. And so we're doing that sort of thing. So if I were to talk about AWS Aurora database, I would index AWS Aurora and Aurora database. So it knows that Aurora is a database, and it also knows that AWS Aurora is a term as well. So I just start typing, and automatically it will figure out, hey, do you mean this? And can start to auto-suggest things. And so that helps, as well as helping figure out some of the concepts that might be relevant inside of the documents as well. And then the ACLs, you know, I should not see things that I'm not allowed to see. And it's really easy when you have entirely public information where everything just goes in and it flows out and you don't care. But we're dealing with people who are dealing with patient records. We're dealing with military organizations with classified information. We're talking about security organizations. We're talking about corporations with top secret proprietary intellectual property that they want to take and secure. And so we need to make that as secure as possible. And then on the front end, we need to do a lot of processing, because we want to take and hide some of the complexities of what's going on. We have complex data models underneath, and yet it has to be so simple that users just kind of, oh, how did you know that I meant in this particular folder? Well, because we're feeding that context directly in there. We're also doing things like term hit highlighting, so you can say, this is where it hits, right here. We're also doing faceting, and doing really intelligent faceting as well, to be able to figure out the context in which you're searching. And of course, those security filters have to be up there up front, and that needs to be injected. So ideally, you know, we could just take this out of the box. We can't. Now, it's great that Cloud Search is now supporting Elasticsearch, but I'm looking forward to the day when I can put all this stuff, just like Aurora, into Cloud Search, but we're not quite there. Hopefully a year from now, I won't be talking about Aurora, I'll be talking about Cloud Search on Solr, and everything's going to be wonderful. But this was hard, and let me give you some indication of what happened here. First of all, I just want to do one thing about the storage. Where's all the documents and the files and stuff like that? The example, I believe in one of the sessions, they were talking about what do you do with a petabyte? Yeah, it's actually during the Snowball presentation. You can saturate your internet pipe with all this information, and it would just, you wouldn't be able to handle it all. So the best way is to actually take and move it. I had just a simple disk before, now I can take a Snowball disk. So if we're talking about a petabyte of information, we're talking about 100 of those boxes that you will be shipping around. And I think that's the best way to move information from one system to another, is just go ahead and do that migration as a physical migration, send it UPS, have it there in a day, have it there in a week or whatever. Then it goes and we just store it into EBS. We can also take the metadata and store all that into Aurora, and then it could just go ahead and go straight into S3. If it's not something you need immediately, it can go ahead and go into Glacier. But we're taking the metadata, the content, and just storing it on disk, and then we're going to go suck it all up. That's the way it should be working. And then we want to secure this information, so we put into place all the web filtering, hook into the enterprise authentication services, the access control lists, the query filters and stuff like that, okay? Now, That's all the bits that actually go into making this thing scale, making it work. But how do you fit it all together? You know, I really wish I could have gotten the CBAS with the lasers, and I couldn't quite figure out how to work that into the presentation. So this is close enough, where he takes the dental floss to get himself out of the scrape. Well, you know, it takes a bit more than that, or maybe it doesn't. So we have built a provisioning portal where we can take and construct essentially a billion document repository as a recipe. And up in the upper right-hand corner are all the bits that would actually go into it, all the connection points that need to be configured and everything else. And we can take and we can manage rolling deployments, fit them into containers. We're working to make this work with Docker as well, and then make that work on top of all the data services and stuff like that. But have Chef be able to go ahead and construct it. But right now, that's how we did it, was we just came up with the recipe, we pushed the button, and there we go. And that puts us in a position where we can now test. We can now actually prove that this can scale to this level. So we built a benchmarking framework, and you can see, you've got the URLs there, you can see how we actually went and did it. We have 8 different benchmarking suites to be able to do it. I'm going to focus on benchmark number 4, which is around concurrent loads and access under multi-user conditions here. So this is what it takes to do a billion documents. First of all, we simulate 500 users loading information constantly. Now, that doesn't happen usually in real life, but basically we have a lot of Selenium servers that are simulating Firefox taking and storing, having a few second think time, and then it'll go and do some more things. So try to be more like a real world environment. Then that goes to the load balancer, that goes to, so there's about 20 of those simulating the 500. That goes to 10 different C3 2Xs of the Alfresco and Share at one level. And then there's the solar, and that took about 20 machines to do that. Now, the reason we did that with that sort of size wasn't because we needed that much CPU, we needed that much ephemeral storage. And then it just took one Aurora 4X large to be able to take and store all those things. What did we get out of this? Well, it's 1 million folders with 1,000 items in each of those folders. It was 15 million transactions to take and store it. And we ended up with a database, an Aurora database that was about 3.2 terabytes of information. And this was the result. First of all, storing this, we were getting a load rate of about 1,200 per second with that particular configuration. That's about 4.3 million per hour with the 10 nodes. If we doubled the number of nodes and we went with an 8X large, we probably could have doubled that to about 8 million, 10 million per hour. Now, we just hired somebody from OpenText who said you'd be lucky to get 2 million a day through the OpenText system. So that's kind of the loads that we're getting. Now, when we're doing bulk loads in the simulation, we were doing it, we were kind of putting it about 70–80% CPU load on both the Alfresco tier and also on the database tier as well. And we could have made it more, you know, we probably could have gotten to that much higher level there. And we were getting about 20 millisecond response time on some of the APIs that we were having. So it was being really responsive and loading really quickly. So that's the left-hand side. Bulk load, just drive, and that was saturating the system. Then we went to user operations of people accessing or storing and doing some casual stuff. And that same thing, instead of supporting 500 users, probably could have supported about 5,000, maybe more, you know, 10,000, 20,000 users, because we're getting the response times and whatever, but the load on the database at that level was only 10%. The load on Alfresco is about 25%, something like that. Solar was about 25%, which kind of indicates if you have the peak, you have to build a data center to the peak. Why can't you just allocate it and then shrink it back down. You can only do that with something like Amazon. You can't do that with an on-premise solution. And in this as well, when we got to 1.2 billion documents, there was no difference between 100 million documents and 1.2 billion documents. I'm calculating that we could have gotten to 20 billion documents with this architecture, and it would have just kept on going. There was no babysitting or anything like that. It just kept on going. It just chunked through and it just went, and we didn't have to do anything. It was just kind of wait for it to finish. So we're talking about over a week to store that, whereas it would probably take months using the traditional approaches. So, what a real difference this is. So, this is what you would have to allocate. It would take you 3 to 6 months to get the money, to get everybody organized, to be able to get all this stuff in place. It'd be questionable scale, little redundancy, and lots of dollars. Whereas with AWS, I'm conservatively saying you could get this up in 30 minutes, probably a lot faster than that. It was probably about 10 times faster than what we had seen before with MySQL as the database. And maybe Oracle would have been as fast, or maybe not quite as fast as this, but it would have cost 10 times as much to get an Oracle instance that would go at that sort of level. And this is elastic. I can have it, the biggest scale machines for the peak load, and then just scale it down to much smaller instances to be able to take and run it. So much more open, cost-effective, and agile as well. And it really is more like, do you want to set up this whole thing over here, or do you just want to make it push button? In fact, probably the analogy I should have had was a knob. Crank it up to 11 to get all the stuff in, then let's go turn it down to 1 or 2 or something like that. So anyway, it just gives you a lot more options in terms of what you want to be able to do. You can repurpose that hardware for other purposes, and just go ahead and retire the traditional, the legacy systems that are in place. And you can have situations where you have emergencies, where you need to be able to load up lots of emergency information, or you can go ahead and set up your own insurance company, which is the vast majority of it is document management, as well as the investment side of the whole thing. But there's a lot of things that you can do with this, but most importantly, you can just be a lot more flexible and agile in how you develop all these things. Now, what happens next after this? So that was working in a multi-AZ, single geography environment. And I do think it's much more complicated if you want to be able to do the same thing. And just like when you post in Facebook, it just shows up around the world. There is a latency in Facebook. There is a latency in consumer applications where the latency doesn't, and accuracy and concurrency doesn't matter. But in business, it often does matter. When you post that equity research report, there are billions of dollars at stake, whether the information gets there at the same time or not. So we want to be able to take this to the next level. We'd like to work with Amazon to figure out how do we get a similar type of Aurora capability, but be able to write to multiple geographies as well as being able to write to multiple availability zones at the same time. There's a lot more that we can do with this as well, because when you get to this sort of scale and all the documents start to look the same, well, we have to do some post-processing to help filter it out and sort it out. Well, there's a lot of machine learning that we can do on top of this. Start to process what is the relationship of not just the documents to the people and their activities, but also to the words themselves, the concepts, the ideas that are stored in there, to be able to take and make recommendations, to be able to auto-classify the information and just kind of sort all that stuff out. So there's a lot more that we can be doing in the future. But I can say that Aurora actually saved us a lot of time, where we didn't have to mess with a lot of stuff. In this architecture, we probably will still be pursuing NoSQL architectures. We're experimenting with Cassandra right now in that sort of environment. We are doing a lot of stuff with Solar as well in terms of replication, geographic replication to be able to get to that sort of scenario. But a lot of multinational corporations want to solve this problem. one big virtual repository where they just put stuff in and get stuff out, and they don't need to really worry about it. So that's kind of all I had for this presentation. I'm really glad that Austin Powers did start the series in Vegas, which gave me some fodder to work with. It was, you can't imagine how horrified I was when I saw that guy just outside the door dressed up like Austin Powers, that he's going to ruin this thing. But do remember that, please go to the website, alfresco.com, aws-reinvent. You can get the Apple Watch. And what the world needs now is evaluation sheets, not just for some, but for John Newton. So please do fill those in, and thank you very much.